Hello, I'm Keatron Evans. This course is designed to get you the needed hands on practice using network protocols or the protocols we use to have computers, phones, and other devices talk to each other and share information. This is one of the most important parts of your fundamentals. I will be using InfoSec Skills platform to do the hands on portion of this course. Let's get right into it. So, what are we going to be covering in this course? Networking, how stuff gets from place to place. And we'll be dealing with very fundamental concepts here to get you to where you're understanding what happens when you click that button and when you open a website and pull stuff down from that website. Now, for more content like this course, you can go to infosecinstitute.com/authors/Keatron-Evans and get, kind of a portfolio of the courses that I teach. Now let's jump right into the skills environment, and we will be using skills to look at some fundamentals of networking here. Once you're into your skills account, go to Cyber Ranges, and I want to take you right to networking. And we're going to look at a few things in here. So first off, this can take you as far as you want to go into networking. You can look at VLANs, you can do DHCP server configurations, and you can do all kinds of other stuff around these particular types of technologies that you're using here to manage your networking devices. Now, one of the things I'm going to recommend for you is you take the time to go through all these courses just to get or all these little exercises here to get yourself used to using these command lines on these different network operating systems. But what I want you to pay attention to and look at with what I'm about to go over with you is we need to talk about the fundamentals of what happens when you connect to something. All right. And for that, I'll be using my Windows 10 VM. And we'll be using Microsoft Paint, which, as I told you earlier, is my real area of expertise. So what I would like to break down for you is one of the things that everybody that's taken this course, you've probably done a million times, which is you open your browser and you go to visit a website. So we're going to use that process, and I'm going to break down for you what happens when you visit a website to show you something called TCP, or Transmission Control Protocol. And this is part of understanding what happens when you reach out and connect to other devices. So let's imagine we've got a website out here. Let's just say it's Keatron.com. And then we got somebody that's visiting that website. We'll just call them customer. And what you might envision in your head is when you visit a website, you just simply go out and say, hey, I would like to visit this website. And then you form a connection, and now you're visiting the website. Okay. Now, that is an oversimplification of what actually happens, because let me kind of illustrate to you in Paint what actually happens, and then we'll look at this in packet captures. So what actually happens is when your computer says you tell your computer you want to visit that website, your machine first sends something called a DNS query to whatever's configured as your DNS server. Now, we need to talk briefly about what DNS is. If I wanted to call my mother on her cell phone, I wouldn't pick up my phone and dial her phone number. You know what I would do? I would pick up the phone, and in that phone, there would be a list of people. That I might call. What happens is when you click that person's name and say call, Your phone then goes into its database, looks up the phone number associated with that person's name, and then your phone dials that number. Now, upon dialing that number, your phone actually connects to a tower that then reaches out and connects to that phone and calls that phone and connects to that phone, and you connect back to it. When you put in to your browser www.keytron.com, there's actually no way for you to connect to keytron.com. Now, there is a way for you to connect to the IP address that keytron.com sits behind. And the way that you do that is you go to that IP. Well, how do you know the IP address of keytron.com? How do you know the IP address of Twitter or Facebook or any site for that matter? The answer is you don't, but you know that domain name. Well, what happens is there are servers on the backbone of the internet, inside your internet service provider, and even inside your individual companies that maintain a list of the IP addresses that are associated with the millions and millions and millions of domains that are out there. So the way that I get to Facebook, or the way that this customer gets to keytron.com, is it will literally ask that server, hey server, what's the IP address for keytron.com? Because I want to go there. And the server responds and says, well, if you want to go to keytron.com, the IP address is, 65.17.38.7. And then I actually connect to that IP address and browse there. Well, that server that holds that information, those are called DNS servers. And the protocol that you use to do that is called DNS. Right? So let's actually watch that happen. I'm going to try to go to infosecinstitute.com, but in the process of doing that, I'm going to have Wireshark running. And this is a tool that captures traffic. So now with this virtual machine up, what I'm going to do is run Wireshark as my sniffer, and I'll use that to show you that DNS process happening. And further, we'll use it to show you the rest of the process happening of connecting to a website. Now, one of the other things that I want you to get out of this is you should definitely be using, or get yourself used to using, Wireshark. And look, I don't want to overcomplicate it, and I don't want to bog your brain down with trying to remember too much. What I want you to do is get Wireshark and use it to do nothing but prove to yourself how you visit websites. That's all I want you to do, is practice figuring out how to build, see how you're visiting a website. So I'm going to do a filter for DNS so that I can only see DNS traffic. And I'm going to open my browser. And in here, I'm going to type www.infosecinstitute.com. And as a result of that, I get the infosecinstitute.com website to come up. Now, how did that happen? Well, the first thing that happened was when we told it that we wanted to go to infosecinstitute.com, our machine actually sent a request, and here that is happening here. Now, my machine's IP address or phone number is 192.168.248.187. It actually sent a message to this DNS server saying, give me the A record for infosecinstitute.com. Now, what is an A record? Well, an A record is a little text file that says infosecinstitute.com is at this IP address. So it's telling me how to get to infosecinstitute.com. Now, I don't have that file yet because this is just me requesting it. Right? Now, what you eventually see is, as a result of me requesting that particular file, you will see that there is a response where the DNS server responded back and says, look, if you want to go to infosecinstitute.com, here's where you have to go. And if we drill down into that, we'll see that it's telling us to get the InfoSec, you have to go to this particular IP address. And it's telling us all the ways to get there. right? Now, as a result of that, our machine will then do something called a TCP connection. So let's clear this and look at what happened right after this. Our machine will do a three-way handshake, or it will reach out to the IP address that came back in the DNS query and say, hey, I want to communicate with you on port 80 or port 443, which are common web ports. So what ends up happening then is once we connect to that port, then we can actually ask the web server for the web page that web server is serving out. All of that I just described happens in literally less than a second, in a split second. So you say, I want to go to Facebook. You tell your DNS server that. Your DNS server says, well, to get to Facebook, you have to go to this IP address. And then you go to that IP address, which is again like a phone number. You connect to it. And then once you've connected, now you can ask, can I have a copy of the page that you're serving out? And as a result of that, you get the page to pop up in your browser. Okay. Now, what does that mean for how we do our day-to-day computing? Well, I want to show you something called the three-way handshake. And this is, again, a fundamental concept that if you know it and understand it, when you come into a cybersecurity bootcamp, it's going to put you a leg ahead of where people are that don't know this particular thing. So what the three-way handshake is when you get ready to connect to a device, you have to tell it that you want to connect. And you also have to tell it the parameters that you want to connect within. For example, if I wanted to connect to this server, which is running an FTP service on port 21, which is what FTP servers run on by default, I would have to tell it that and then do my FTP commands. If I wanted to connect to it over something called Telnet, I would have to tell it that and then connect to it over that port and then do Telnet commands. As a matter of fact, what we're going to do now is I will show you that process. So I'm going to start the Telnet service. Now that the Telnet service is started, this machine is the IP of 192.168.248.187. I'm going to now run Wireshark. And remember, IP addresses are like phone numbers for your computer, and every computer has a unique one as you connect to the internet and things like that. So I'm going to create a filter. Remember, I showed you these filters earlier and said you probably wouldn't be able to type this because you don't type it every day. Well, I do type these every day. So what I want to do to keep me from seeing a whole bunch of other traffic here, I'm going to create a filter that only shows me traffic to and from this Linux machine, which is 192.168.248.251, and this Windows machine, which is a 247 address, or actually 187 address. See, everybody makes mistakes. So to do that filter, it would look like this. Now this should look familiar to one of the things I showed you earlier in the course or in these paths here. So I'm going to say 251 and this machine, which is 187. And since we haven't tried to connect, there's no traffic that meets that criteria. Therefore, all the noise goes away. Now I'm going to come to this machine and do a telnet session to the other. So I'm connected. So now I'm going to log in. So now I'm logged in. I'll do a directory command and then I will exit the telnet session. So what just happened there? Well, let's go look at the traffic. Very first thing that happened is the Linux machine, which is 251, sent a packet to the Windows machine here. Now, what is a packet? Well, let's look at that. And again, you get to see some of my amazing Microsoft Paint work. A packet is like a piece of data, okay? If I'm going to send you a block that looks that big, I can't send that across a network because no network cable or no network connection is wide enough or doesn't have enough bandwidth to handle that. So what do I have to do? If my pipe or the hose that I'm trying to send my data across is this thick, but the data that I'm trying to send is like this, how do I get this data from this side to this side? Well, the way I do that is I take this big piece of data and I break it down into a whole bunch of little pieces that look like this. Those pieces are called packets. And now I can send those packets across a medium that can actually handle them. And eventually they make it to the other side like this. Well, what's happening here is the first machine just sent an actual packet to the other side saying, look, I want to connect to you. This packet's only to let you know I want to connect to you on port 23. Then if you look at the IPs here, 251, 187, 187, 251, the second packet is 187 responding, saying, hey, okay, you're saying you want to connect. I'm responding back saying I'm acknowledging that. And then the next packet is the original machine responding back to that saying, okay, I'm acknowledging that you have acknowledged that you want to connect. And therefore the connection happens at that point. So after that connection, you can see there's a bunch of data going on. And then at the very end, when one side said, I don't want to talk anymore, it literally said that with, hey, FINAC, which means I'm done talking. That's coming from 251. Then 187 says, hey, AC, I'm acknowledging that you don't want to talk to me. And then 187 says, and guess what? If you don't want to talk to me, Fin act right back at you, buddy. I don't want to talk to you either. And then finally, the original machine says, okay, I've acknowledged that you've acknowledged that I don't want to talk to you. I've also acknowledged that you don't want to talk to me. And then at that point, the session's over. This is built into the protocol. Every device in the world that connects, when you connect to a website, when you connect to a router, when your TV connects to Netflix, every device in the world that connects over the internet or a network does so this way, at least in your world, as far as what we're talking about now. Every time this happens. So for example, if you go on to be a forensics investigator or a incident response person, it is going to be paramount that you're able to look at a packet capture like this and look for connections. Well, how do you know a connection happened? Well, if there's a SYN-ACK pattern, 100% guaranteed a connection happened. It's not even debatable. If there's a three-way handshake, that's a connection. People have went to prison over that handshake. When we prosecute people for cyber crimes, for connecting to sites that's a felony to connect to, you know how we prove they connected? We prove that they committed a three-way handshake. So this is one of those fundamental things. This is a true foundational thing that you're never, ever, ever going to get away from, no matter how far you go into cybersecurity. So you need to get comfortable and understand three-way handshake happens every time. It's part of a TCP connection. And generally, when you disconnect from a device, you will always do it with the four-way combo that says, I don't want to talk. And this is actually exactly how we talk to each other as humans. If I were talking to you on the phone, let's pretend like your name is Tux, okay? And we're having a phone conversation. And I say, hey, you know what, Tux? It's been nice talking to you, but I got to get back to work. That's me saying FINAC. And then Tux responds with an ACK and says, all right, I understand that. That makes sense. Because honestly, I got to get back to work too. And that's Tux saying FINAC back at you. I got to get to work as well. And then finally, I say, all right, well, good talking to you. Talk to you later. click and I hang up, and that's the final act. That's the end of the session. So while this protocol sounds very chatty, the reason it's like that is because it was actually built by us, and it's based on the same way that we communicate with each other. And that's part of the flaws that you're going to go on to learn about as you progress into cybersecurity. The fact that it's built to communicate like us is part of why it gets hacked every single day. Okay? And that's just TCP. But again, when you connect to a device across the internet or the network, you're doing so via TCP every single time. Now, with that, these have filters and things of that nature as well. One of the things I want you to see here is if I were to grab a single packet here and say follow TCP stream, we can see that entire session, including the username and the ever important password to connect to the server. Why can we see that password in the traffic? Well, because Silly Keytron used a clear text protocol. We use regular old telnet, which is clear text, to connect to the other side. Now, this is something you'll learn about in the securing network protocols. What should have happened there is we should have used an encrypted protocol. Think back to the cybersecurity fundamentals in the first course in this path, and we talked about the CIA triad. Well, now we're talking specifically about the confidentiality piece of the CIA triad. We should have been concerned about confidentiality here, and we should have used an encrypted way to do this communication so it wouldn't look like this. Now, when we get to the network security fundamentals course, I will show you the difference between what this looks like and what an encrypted version of this looks like. And you'll see that it's very different, right? So that is part of the fundamentals of TCP, which is probably the most important protocol as far as understanding the fundamentals of how you connect to stuff. Now, when you connect to a website, you connect to port 80, and then on that port 80, you do web traffic or HTTP traffic. But that doesn't change the fact that it starts with TCP. We just connected via telnet, port 23 right there, but we did it over TCP. Notice in the protocol field it says TCP. If I were to right now connect to InfoSec Institute again, I want to show you something. Even though this is now not telnet, this is web traffic, guess what? If we go look at it and break it down, what you're going to find is we connected, since InfoSec forces SSL, we connected over port 443. But look at that. It's still actually TCP traffic. Right there. That's where we connected to InfoSec. All these little 443 packets. Now we could filter that. We could say TCP port equals 443, and then we can see just that, 443 traffic. But the point I'm making here is even though it's 443, it's still going over TCP. You can never get away from TCP. Now the difference is because it's over 443 and it's encrypted, if we grab one of these and follow TCP stream on that, instead of seeing Keytron's password of InfoSec 458, what we see is that. Good luck breaking that encryption and figuring out what my password is. But even though this is HTTPS, it still sits on top of the same three-way handshake or TCP highway that we always use to connect to things. If I connect it to Netflix, I'll show you this. If we went to netflix.com, and we sign in, and yes, I really do have the cross-site script at gmail.com. Gmail address. They gave it to me way back before anybody knew what cross-site scripting was. And of course, now I can't remember this password. Maybe that. Yeah, we can definitely edit this, me messing up the password out here.
We'll make sure you show the password first.
Yeah. And then you can blur out like everybody's name except for mine. You guys can do that, right?
We can do that.
Yeah. So now that we're connected to Netflix, I'm going to go ahead and click on Keytron here. And I'm just going to play this Night Stalker movie. And you can see Night Stalker playing. But I want to show you something that's interesting. So this is enough. We started it. Let's look at that session to Netflix and see what actually happened when we watched the Netflix movie. So I'm first going to do TCP contains. This is a real filter. Netflix. And we can see the Netflix session right there. Right? If I grab that and follow TCP stream, this is us going to netflix.com. And again, that's encrypted. But then I want to show you something that happened shortly after that. Shortly after we visited netflix.com, we also introduced a whole bunch of what we call UDP traffic. Right there. Now I want to show you something about this UDP traffic. This UDP traffic, which is now the little brother of TCP, basically is coming from what we call an AWS location. We can see that right there. Now, what is AWS? AWS is Amazon Web Services. So how many of you knew that every time you watch a Netflix movie, you're actually streaming that movie from an Amazon server? And furthermore, think about this. Amazon and Netflix are competitors because Amazon has Prime, Netflix has Netflix. So how crazy is it for Netflix that they have to store their data and their content on servers that are owned by their competitors? Now, this is because this relationship happened back before Amazon was really into streaming. These are the kinds of cool, fun things you find out as you start digging into your network fundamentals and understanding what happens. Because what's going on here is when you watch a video, when you connect to Netflix, you do that over TCP. And now that's taking us into the little brother of TCP, UDP. Because UDP is not an actual connection. With UDP, you actually just send packets back and forth. With TCP, it's like I hold your hand and we do a handshake and we kumbaya each other and we're standing there holding hands communicating because we're sending large amounts of data back and forth to each other. But with UDP, it's as if, what if I just need to give you a little tiny message? If I just need to say, here's the IP for Facebook. Well, that's a tiny message. We don't need to do a whole three-way handshake to build up this whole communication just to send one packet, right? It doesn't make sense to do 3 packets just to send 1 packet. So for UDP, we just take that little message and throw it. And then we turn around and walk away. We don't care if they get it or not. We just threw it. Now, why is that? Because what happens is if the Netflix movie is 5 gigabytes in size, remember we talked about packets. You can't pull that whole 5 gigabytes down at one time. So when you're actually streaming, You're breaking that movie up into millions of tiny pieces and sending one piece at a time at a very, very high rate of speed. That's what streaming is. UDP is better for streaming than TCP because if we stream with TCP, every packet would have a 3-way handshake and a 4-way combo to close it down. So 7 packets of overhead per packet of actual movie data. It's not efficient. Therefore, UDP was created for that type of thing. Whenever we stream video, whenever we stream audio, we're doing that mostly over UDP, which is the little brother of TCP. Now, if you go into a class like Security Plus or some entry-level cybersecurity course, they're going to give you more foundation and more details around the difference between UDP and TCP. But for now, just remember, TCP is the foundation of us connecting to anything. And UDP is what we do when we don't need the overhead of connecting. We just need to send small bursts of data, right? And that creates a great break for us on when to use one over the other. And as you can see, we use TCP for connecting where we might send large amounts of data, and UDP where we're sending small pieces of data or a small piece of data. And that hasn't changed since these protocols have existed, right? That's all the fundamentals I want you to think about now. But remember, before you go into a course, I would like for you to add to your plate, go to your skills account, if you have one, go to the networking part of the cyber range and go through the exercises there. I think you will find some real value in actually doing that. Thanks for watching, and I hope you got some value out of this course. Don't forget, TCP is the foundation and how we connect to everything in our computing world today.